Hello and welcome to today's learning. This week we're taking a look at database systems. My name is Renee Dyer and I'll be your guide today as we explore data, the database, database design, and database management systems. We often hear that we are surrounded by data. But just so we're all on the same page for this study session, we're going to use Merriam-Webster's definition of data. Merriam-Webster defines data as factual information used as a basis for reasoning, discussion, or calculation. So what's a database? A database, in the most general sense, is an organized collection of data. More specifically, in computing, a database is an electronic system that allows data to be easily accessed, manipulated, and updated. In other words, a database is used by an organization as a method of storing, managing, and retrieving information. Database design is the organization of data according to a database model. Stakeholders and designers work together to determine what data they want stored and how they can begin to fit the data to the database model that they prefer. Database design aims to meet the requirements of the users, be they programmers, employees, or clients. Database design also seeks to provide optimal performance to all users. A database management system, or DBMS, is a collection of programs that enables users to create and maintain a database. The DBMS is a general-purpose software system that facilitates the processes of defining, constructing, manipulating, and sharing databases among various users and applications. For a long time, database management systems were based on tables and the relationships between those tables. But that all changed with non-relational or NoSQL database designs that we'll talk a little bit more about later in the presentation. Humans have first survived as a species largely in part due to our ability to access information or data. Our ability to recall and pass on what we know, and we're going to briefly discuss how it all got started, how we stored, recalled, and passed on data throughout human history. Let's start by acknowledging that the human brain is the original and to date the most powerful storage system available. But we needed a means to transfer our knowledge, and we did that through cave paintings originally. But cave paintings had a critical point of failure. They weren't movable. So man started using stone tablets, and stone tablets provided accessible and portable data storage. But they were laborious and difficult to transport. So man began using papyrus or paper, and this replaced the stone tablets and were much safer and lighter to transport. In fact, paper remained the primary means of data storage through the 19th century. In 1725, punch cards were invented, but they weren't used to store data until 1832. And in 1890, Herman Hollerith invented machine-readable punch cards. And at about the same time, an insurance company started using the filing cabinet, which was an early form of multi-file compression data storage. In the 20th century, there was an explosion of data storage. In 1951, magnetic tape began to replace punch cards. It could store as much data as 10,000 punch cards. In 1958, hard drives were introduced by IBM, but they were too big and too expensive to use for personal data storage until the 1980s. In 1969, floppy disks changed data storage as they knew it. One 8-inch floppy disk could store an amazing 80 kilobytes of data. And in the 1990s, the World Wide Web began. Of course, not as we know it now, but in 1990, data storage was again revolutionized with the advent of off-site storage. Online data could be backed up to remote locations, which again increased our ability to store data. And can you believe that it was only 1998 that flash drives became the first portable hard drives with the capacity to store much more data than floppy disks? With all of this talk of data, that brings us to databases. The evolution of databases would not have been possible, nor necessary, without improvements to and the increased capacities for modern data storage. We're all familiar with library databases. SHSU's Engine Orange databases are purchased by the library from vendors as part of a subscription service. But we aren't going to talk about databases from the user end today. Today we're going to explore databases more from the developer and programmer's perspective. So for example, let's take a look into our online banking account. Your bank first authenticates your login using your username and your password. It's the database operating behind the scenes that evaluates your username and password combination and then provides you with access to your account. The database filters your transactions to display them by date or time or however you request. A database such as this gives you a wealth of information. And as we've all read about, the information contained within databases is valuable and vulnerable. In fact, in 2014, Yahoo's database breach impacted over 3 billion users. And it wasn't alone. eBay, Ashley Madison, Target, Equifax, Uber, PlayStation, and even the United States Government Office of Personnel Management have had their databases breached. So how do businesses and industries figure out what needs to be in their database? They go through database design. And remember, database design is the process of organizing data according to a database model, where stakeholders and designers work together to determine what data they want stored and how that data can begin to fit into their preferred database model. There are many database design models. Some that you may have heard of before are the flat database model. This model is very much like a spreadsheet. The hierarchical model, this model has more of a tree structure. The data is stored as records, which are connected to one another through links. The network model, this model represents data as records, conceived of in flexible ways and objects to represent their relationships. The relational model represents data in numerous tables, organized in such a way to create relationships between all the tables. An object database is a database in which information is represented in the form of objects instead of tables, like relational databases. So when we talk about relational databases, you can begin to think SQL. Relational databases, or RDBs, as they're sometimes called, diverge from spreadsheets by building powerful relationships between different tables. In fact, relational databases have the largest market share of database models. Relational databases organize data in table formats, and they logically group together similar data and provide links between tables through relationships are common keys. In fact, SQL is considered the industry standard. But relational database models had a problem. In the 1990s, in part because of the impedance mismatch problems occurring in relational databases, where data tables ended up being too difficult to force together, the object-oriented database model came to be, where information was represented in the form of objects instead of tables. But these didn't catch on enough to replace the popularity of relational databases. And that's where non-relational databases came into being. Non-relational databases are extremely varied in their structure, and thus they are more reasonably defined by what they have in common. The first thing they have in common is that they do not use the relational model. They are often open source. They are designed to run on large clusters. They are based on the needs of 21st century web properties, and they can more easily handle massive amounts of unstructured data, like articles, photos, videos, blog posts, and social media data. There are four main broad categories of non-relational databases. The key value database is considered the backbone of the non-relational database family. The column-oriented database, the document database, and the graph database. The graph database stores data that's interconnected and best represented as a graph in nodes or links. So you can think of it like this. Relational databases are structured, kind of like an old phone book, that stores phone numbers and addresses in a very logical and sequential way. But non-relational databases are document-oriented or graph-oriented, and their information is distributed like file folders that hold everything from a person's address to their phone number, to their Facebook likes, to their online shopping preferences. It's much more complex. And that brings us to database management systems, or DBMSs. A database management system is specially designed software used to capture, hold, and analyze data. It typically has 6 functions: to organize data, to integrate data, to separate data, to control data, to retrieve data, and to protect data. First, let's talk about the SQL programming language. In this illustration, SQL is the programming language which is used to access the database management system and the database. It is represented right here by API, which stands for the Application Program Interface. The app, or the user, writes SQL commands which are processed by the database management system. Why is it called SQL? Well, SQL was originally invented in the 1970s, and at that time it was called SEQUEL, for Structured English Query Language. But SQL, the word, was already trademarked by an airplane company, so IBM changed the acronym to SQL, Structured Query Language. And this is the American National Standard Institute's, the ANSI Standard User and Application Program Interface for relational databases. The NoSQL came about in the early 2000s when Johan Åkesson needed a simple Twitter hashtag to advertise a meetup at a San Francisco tech conference for the new types of databases that were emerging at the time and thinking outside of the table. NoSQL are extremely varied in their structures and thus more reasonably defined by what they have in common. And finally, we could talk about databases for much longer, but I think this is an important way to close our lesson. At the beginning of this lesson, we talked about the growth of information and access to data. In 2012, Eric Schmidt from Google reported that human beings add more data in just 2 days to our collective body of knowledge, as we have from the beginning of time all the way up to 2003.